Hi, this is Gina Piscatelli with a presentation for students in Anatomy and Physiology 1 at Madison Area Technical College. It introduces the processes involved in chemical bonding, which occurs between atoms and ions. So now that you know a little bit from the previous lectures about the structure of atoms, as well as the formation of ions and how they behave, let's look at how atoms can join together and ions can join together. And this activity is called bonding or chemical bonding. And there's two ways that the bonding can happen. One way is called ionic bonding. The other way is called covalent bonding. In the process of ionic bonding, two ions of opposite charge are attracted to one another. And this usually involves a metal and a non-metal, which are on opposite sides of the periodic table, if you remember your general chemistry a little bit. The compounds that form from ionic bonding, of course, are called ionic compounds. One type of ionic compound is a salt, and we'll look at that in a little bit. In the process of covalent bonding, two atoms share electrons. These shared electrons move between the two atoms that are bonded together, and the cloud of electrons moving is a physical structure that we call a covalent bond, and there are two electrons, one from each atom, in a covalent bond. So let's look at some examples of each type. Here's an example of ionic bonding involving sodium and chlorine. When these two atoms, which are neutral initially, are put into water, they both ionize. So the first thing that happens is sodium ionizes and forms a cation. Then the chlorine ionizes and forms an anion called chloride ion. So the sodium is positively charged, the chlorine is negatively charged, and they are attracted to one another because opposites attract. Compounds that form in this way usually form three-dimensional crystalline structures, and we usually call them salts. So in the previous example, using sodium and chlorine, that makes up ordinary table salt. These salts easily dissolve in water. Notice in the picture of the crystal here, the sodium chloride crystal, that one ion is surrounded on many sides by ions of the opposite charge, not just a 1-to-1 ratio. There are several ionic compounds that are important in the human body, and the table on this slide lists a few of these, some of the major ones anyway. Calcium chloride, potassium chloride, and sodium bicarbonate are electrolytes or ionic compounds that we will discuss when we talk about the nervous system and when we talk about pH balance. These ionic compounds are found in body fluids such as urine, blood, the fluid in between cells called intercellular fluid, or within a cell's cytoplasm. You may have heard this term electrolyte in the past, and electrolytes are simply ionic compounds found in body fluids. And usually when people talk about keeping an electrolyte balance, they're talking about making sure that your hydration status is stable. But the definition of an electrolyte is that it can dissociate or dissolve, ionize in water, and that it can conduct an electrical current in water. So electrolytes are definitely important to the body. They participate in metabolic reactions. They affect your osmotic balance or your hydration status because they affect how water moves across cell membranes. Electrolytes are also really important for normal nerve and muscle tissue function. Electrolyte imbalances or ionic compound imbalances can cause a range of effects. In some cases, muscle cramps would occur or bones would become brittle, but some more severe imbalances can even cause coma or cardiac arrest. The other type of bonding that we need to talk about is called covalent bonding. And instead of ions forming, in this case what will happen is two neutral atoms will just share electrons. So in this case, no ions form. An atom does not lose or gain an electron. Rather, atoms share, and they don't completely donate or accept these electrons. It usually occurs between two atoms that are either both nonmetals or both metals, so kind of like with like. One covalent bond is composed of two electrons, and you can kind of see that between the two hydrogen atoms that are shown on this slide. This is a single covalent bond involving two electrons, and these electrons move between the two atoms, so they rotate back and forth between the two atoms, but they spend the majority of their time in the middle. Now there are also double and triple covalent bonds, and in this case more than one electron pair would participate in the combining or joining of two atoms. For example, when these two oxygen atoms bind together to form oxygen gas, or O2, each atom shares two of its electrons. Therefore, in between the two atoms, you will find 4 electrons. This is really equal to 2 pairs, so we call it a double bond. In the case of nitrogen gas, one nitrogen atom would really need 3 electrons to fill its valence orbital, and so a triple bond forms between 2 nitrogen atoms. So normally nitrogen has 5 electrons in its outer orbital, but when it can kind of share 3 of its neighbors, now it's got 8. So that's an example of a triple covalent bond. Some other common covalent compounds that we will encounter are carbon dioxide, shown here in both the structural formula as well as just the written molecular formula. So carbon dioxide, ammonia, which is NH3, and water. And water is the next topic, the next lecture topic. Thank you very much, and that's all for bonding.